Hello everyone, welcome to VPT classes. Today we'll discuss chapter 1 of class 8 rational numbers. So first, before going to discuss rational number, first one is, so in number there is first one is natural number. Natural number. So what is natural number? Here natural numbers are counting numbers. Counting numbers we are also telling that one, that is natural number. So 1, 2, 3, 4 up to infinite. These all are the natural numbers. Now if we discuss after natural number, the second one is whole number. So what are the whole numbers? Whole numbers are natural numbers and including 0. So whole number we can say also all natural numbers including 0, that is known as whole numbers, including 0. So like that we can write 0, 1, 2, 3, 4 dot like that. So it will go. Next, after natural and whole number, then we write integers. What are integers? Integers are those numbers which are positive as well as negative. Otherwise, you can say also whole numbers and all negative numbers. Whole numbers and all negative numbers. Negative numbers are -1, -2, -3. All negative numbers are there. These are known as integers. Whole numbers 0, 1, 2, 3, 4 like that, and this side -1, -2, -3 dot dot. After that, rational number. Rational number, this is our topic, rational numbers. So here rational numbers are those numbers, it can be written in the form of P by Q. It can be written in the form of P by Q. Where? Form of P by Q. Where P and Q both are integers. Both are integers and Q not equal to 0. Q should not be equal to 0. Like suppose the number is 5. 5 is a number. This one is a natural number, and this is also a whole number. This is also an integer. But 5 we can write in the form of 5 upon 1. This is possible. So here 5 is P and 1 is Q. But Q should not be equal to 0. So that is not equal to 0. So 5 is also a rational number. Like that, if you will take another example is 0. 0 we can write in the form of 0 upon 1. P and Q form, P upon Q form, and here Q is the denominator, that should not be equal to 0. So 0 is also a rational number. Okay. Now we will discuss all the properties of rational number. So first one is closure property. What is that property? First one is closure property. So here we will discuss actually the closure property of whole numbers, closure property of integers, and closure property of rational number. Addition, subtraction, multiplication, and division. These are all things. First, in this closure property, we will discuss the whole numbers. Whole numbers, its addition we will discuss. Whole numbers addition. First one is addition. Then subtraction. Second one is subtraction. Third one is multiplication. Then fourth one is division. So these all things we will discuss. Fourth one is division. Now here first we will check whole numbers. What is closure property? First, the closure property is that suppose there is two number. A is one number, another one is number is B. If we add A plus B, the result is that known as closure property. Suppose 2 plus 3, 2 plus 3 equal to 5, that is known as closure property. Direct answer will get there. So here whole numbers addition will take. Let's take an example of whole number. Let's 0 is a whole number. 0 plus 3, 3 is also another whole number. 0 plus 3. So 0 plus 3, the result is 3. 3 is also a whole number. Like that, we can take 5 plus 4, that is equal to 9. So 9 is also a whole number. So here what we have got, if we add two whole number, the result is also a whole number. Here also if we add, the result is also a whole number. So we can write here whole numbers are closed under addition. Whole numbers are closed under addition. Why addition that is closed? Because when we add two numbers, the result we are getting, that is also a whole number. Now we'll check subtraction. Let's take one example. 5 is a whole number and 3 is also a whole number. If we subtract, the result is also a whole number. So it's possible. But if you write 0 is a whole number and 3 is also another whole number, if you subtract 0 minus 3, the result is minus 3. That is not a whole number. That is not a whole number. So that means whole numbers, we can write also whole numbers are not closed under subtraction. Okay. Next one is multiplication. So here we'll check. Let's 0 is a whole number. If you multiply 0 with 11, 11 is also a whole number. So 0 into 11, the result is 0. 0 is also a whole number. It's possible. So similarly, 3 is a whole number. If you multiply another 3, the result is 9. 9 is also a whole number. If any one is not possible also, we can write that is not closed under multiplication. But here each and every number you will take also whole numbers. Any number you can take two numbers, then you can multiply that one. If results are whole number, then it is also closed. So we can write here whole numbers are closed. Whole numbers are closed. Numbers are closed under multiplication. Under multiplication. Then last one is division. Then division. Division will check the same thing. Suppose 3 is a number. 3 is a whole number. If we divide 2, the result is 3 upon 2. So 3 upon 2 is a rational number. That is not a whole number. That is not a whole number. So it's not closed under division. Not closed under division. So which one satisfies that rule? The first one is that addition and multiplication. These two are closed under addition and multiplication. That is in whole number. Next one we will discuss the integers. Integers closure property. Integers closure property. So here also we will write the same thing. Integers closure properties. First one is addition. Second one is subtraction. Third one is multiplication. Fourth one is division. Same thing we will check here. Addition, subtraction, multiplication and division. Now first of all, that integers addition. Next, suppose let's take a number is 3, another number is 5. These two numbers are integers, positive integers. or you can take -3 and +5. If you add these two numbers, -3 and +5, if you add, the result is only 2. So 2 is also an integer. Similarly, take another example, suppose 0. 0 is also an integer. If you add with -2, -2 is also an integer, negative integer. If you add, the result is 0 plus -2 equal to -2. Similarly, take 3. If we add with -5, the result is -2. So these all numbers are integers. All numbers answers are integers. So integers are closed under addition. So we can write here integers are closed under addition. The addition. Similarly, second one is subtraction. So this is closed under addition. Now we'll check subtraction. So here let's take one integer is 5, another one the integer is 7. So these two are the integer. If you subtract 5 upon 7, the result is -2. 5 upon 7 is -2. 3 minus 3, the result is 0. 2 minus 4, the result is -2. So everywhere these all numbers are integer. So all numbers are -2, 0, -2. These all numbers are integer. So we can write here integers are closed under subtraction. Under subtraction, because it is possible. So this one is also possible. Now multiplication. Let's take two example of integer, like 0 is one integer and multiply with -3. -3 also an integer. If you multiply, result is 0. 0 is also an integer. This is also an integer. Similarly, -2 multiplied with -4, the result is +8. That is also an integer. So here also we can write it is closed under multiplication. So integers are closed under multiplication. So this is also possible. And next one is division. Division, this one is possible. And here we will take one example. Suppose one number is 3, another number it will divide 2. 3 divided by 2. 3 and 2 both are integers. If we divide 3 divided by 2, the result is 3 upon 2. That is not an integer. That is not an integer. So we can write here integers are not closed under division. Not closed under division. Okay. Next, we'll write that is not a closed. Next one is rational number. The third one is rational numbers. We know that one, rational numbers. All numbers, that whole number, natural number and integers, all are rational number. But we can write in the form of p by q, where p and q both are integers, but q not equal to 0. Q should not be 0. So let's take the same rational numbers, addition, then rational numbers, subtraction, then rational numbers, subtraction, next rational numbers, multiplication, then division. So our rule is that we have to check that actually is it satisfied the rule of closure property or not. So addition, here rational number, let's take one example of rational number 2 upon 3. That is a rational number. If you add with another number, suppose 3 is a number, 3 is also a rational number. 3 means 3 upon 1. If we add, the LCM is 3, then this one is 2 plus 3 divided by 1, 3 3 is 9, 2 plus 9 equal to 11 upon 3. That is also a rational number. Similarly, take another example, suppose 0 plus 5 by 2. The result is also 5 by 2. That is a rational number. So rational numbers are closed under addition. Rational numbers are closed under addition. It is possible. Same thing also in subtraction. So let's take one example, that is 2 upon 3 is a rational number if we subtract 3 upon 2. From 2 upon 3, if we subtract 3 upon 2, LCM is 3, 2, its LCM is 6. 6 divided by 3, 2 2 is 4, minus 6 divided by 2, 3 3 is 9. 4 minus 9 equal to minus 5 upon 6. So it is also a rational number. Similarly, 5 minus 0. 5 is a rational number, 0 is also a rational number. The result is 5. It is also a rational number. So rational numbers are also closed under subtraction. Closed under subtraction. That is applicable in closure property. Next, third one is multiplication. So let's take one example, 3 divided by 2 into 0. If you multiply, result is 0. 0 is also an integer. And if we write down 0 is also an integer and 0 is also a rational number. And 5 upon 4 multiplied with 4 upon 5. If you multiply, then 4 4 cancel, 5 5 cancel, the result is 1. 1 is also a rational number. So we can write rational numbers are closed under multiplication. Closed under multiplication. And next one is division. What is division? Here, if we take one example, suppose 0 is a number. 0 divided by 4 upon 5. 0 divided by 4 upon 5. So that means we can write 0 into 5 upon 4. The result is 0. Okay. So 0 is also a rational number. 0 is also a rational number. But if we write 0 is also a rational number, 1 is also a rational number. If you divide 0 divided by 1, the result is not defined. We can't get a value of this number. 0 divided by 1, that is not defined. So it is not a rational number. So we can write it is not closed under division. Not closed under division. So except the division, each and everything is possible in closure property. These all are closed under addition, closed under subtraction, closed under multiplication, but division is not possible. Why? Because the value is not defined.